Hello, everyone, and welcome to Module 5. In this one, we're going over unsupervised learning, and specifically, we're going to dive into clustering with k-means. So last week, we covered support vector machines. You dove into that really fantastic video by StatQuest, and we talked about actually implementing those. We went over, in that Python exercise video, we went over end-to-end. How would you even go into a classification problem? So, looking at the data, getting to know it, going through modeling step by step by step. When do you switch to the next model? How do you compare and contrast models? Going into evaluation metrics and cross validation and all of that fun stuff. So, hopefully, you all enjoyed it. I definitely did. It was really fun. But this week, we're going to go over clustering. So we're going to focus on the k-means algorithm. That's the most common one used in data science. So we're going to really focus in on that, specifically choosing the optimal number of clusters and applications in customer segmentation and market research. Some optional content that I'm not going to record today, but I am going to post on Brightspace is dimensionality reduction and specifically principal component analysis, PCA. I was hoping to cover all of it, and then I realized that it just wasn't going to happen this semester. We were going to cover just way too much, and I wasn't. It was just too much for 8 weeks. But I am going to at least show you some neat stuff you can do with PCA. It is helpful, but when I was reflecting back on everything I've done in industry, k-means, I would much rather you really, really understand k-means than halfway understand both k-means and PCA. So I'm going with k-means. So let's get started. I'm really hoping this is recording correctly. We'll see. I'm actually going to pause it and see. So as a reminder, supervised learning, we are taking raw data and we have an idea of what we want to do. It's labeled in some sort of way. So we've got a column that we want to predict. We've got some sort of value, or in the terms of classification models, we've got a category we want to predict. And we, the supervisor, are saying, hey, here's our data. I'm going to split it up for you. Let's train you, figure out what we can learn, figure out some patterns. I'm going to tell you what I want. You, computer, learn some stuff, create an algorithm, and let's go. We process and we get our output that we want. In contrast, unsupervised learning, we still have that same input of raw data, but you notice that it's unsupervised because us as the supervisor, we're very much less involved. We're still dealing with that same data, but there's no training data set. It's an unknown output. And it's not that we don't know what we want, it's that there's not a specific column, a specific value that we're trying to predict. We're essentially giving the algorithm, the computer, all of our data, and we're saying, find patterns. In the case of k-means clustering, we're saying, if you throw all of this data out, what sort of patterns start to emerge and what sort of clusters, segments start to emerge? And then from there, the only thing I don't like about this image is that the output still looks the same as the previous. But the output is going to start saying, oh, this data kind of looks the same over here, and here's another group of data that kind of looks similar. One thing to note about unsupervised learning, though, is that it's always going to give you an output. No matter how bad your data is, no matter how much it doesn't work for unsupervised learning, it will give you an answer. But it's up to you to figure out if that answer is actually the right data, the right algorithm, the right answer that you should actually use. So that's what we're really going to focus in on, is the business case, because it's really easy to spin up a k-means cluster, make it whatever. It's another whole thing to figure out, should you actually use it? So again, review of unsupervised learning. We're finding unknown patterns, unknown to us, in data through clustering or association rules. We're focused in on clustering. Some attributes: it uses unlabeled data, which means that the columns have column names, but we don't have individual rows labeled. So like in our previous examples, the wines were labeled as good quality or bad quality. In the case of unsupervised learning, we would essentially say, here are all of our wines. What sort of patterns are going on here? What sorts of wines are similar to each other and different from others? It attempts to find patterns in data. And by attempts, I mean it definitely will find something, even if it's not a good pattern. It's going to find something. And unlike supervised learning, the algorithm does much of the heavy lifting. There's not a lot of retraining and tweaking and parameter changing. Once it's done, it's done. The only real tweaking there is changing the K of K means, so how many clusters should you have, and then changing some of your data, so getting your data ready for the algorithm, and then the interpretation piece is where you're really, really needed. But since it's unsupervised, you're not doing a lot of the heavy lifting right there in the middle. A starting example, so I am personally recording this on Super Bowl Sunday. I am recording this, I don't have a watch on me, but it is before the game has kicked off. I'm a huge Chiefs fan, so hopefully I am not going to look really dumb at the end of this because I have a lot of Chiefs stuff in here. But I'm going with the Chiefs example, the Super Bowl example. So a few stats here. A 30-second Super Bowl ad costs nearly $8 million this year. If you have been in the US for any amount of time, Super Bowl Sunday, there's tons of food ads and things that you can get. Lots of deals and things going on for Super Bowl Sunday. The halftime show brought in nearly 130 million viewers last year. I actually don't know if this year is going to have less because people are protesting the Super Bowl or more because Kendrick Lamar, I would assume, is more popular than Usher. We shall see. But the Super Bowl in general, it's not just a football game. It is the football game of the year. It is a marketing bonanza, palooza. It is the marketing event of the year. So if a business is going to use today as any sort of marketing event, they are going to dive in and they want to use this to their advantage. This is a big deal. And the one key piece of information that is going to set apart a good business strategy from a bad one today is that businesses need to understand that not all fans are the same. And honestly, anyone watching the Super Bowl honestly might not even be a fan at all. Any viewer in general, they're not all the same today. There are different segments across if you think about the Super Bowl. And if we actually start to think about what data is available, and if we had access to that data, think about how many interesting things we could start to learn. So this is a completely theoretical example. I wish I had this kind of data available, but I thought this would be kind of a fun one to play around with. So think about if we were the NFL or if we were a business marketing today, think about if we had some of these data points. So if we had team affinity, so if you were a viewer and we knew if you were a Chiefs fan, an Eagles fan, not a fan at all, fan of a team that's out already, whatever it may be. Your location today and where you normally live, tickets purchased. So have you purchased any NFL tickets this year, previous years? Did you go to a game? Season viewership statistics. So did you watch any games this year? And if so, did you only watch your team? Did you watch other teams? Do you watch every single football game possible? Do you have it on in the background? Do you not watch football ever? That kind of depends. And then game day activity. Do you watch with friends? Do you watch at home? On this Super Bowl Sunday, what are your plans? Are you going to watch at a Super Bowl party? Are you going to watch alone? Are you going to watch at all? So if you think about all of that fantastic data, if you had access to it, think about the amazing things you could do with an did I say $8 million? Yep, $8 million 30-second Super Bowl ad. If we start to segment some of those Super Bowl viewers, you would start to find some patterns that emerge. And again, this is completely theoretical, but this is what I think we would start to find. Now, based on some of these statistics, I think we would start to find some segments like this. And just to know, all of these images are AI generated because I couldn't find good stock images. They're not great images. Someone come up with a better AI image generator. But anyway, my theory is that we would come up with one segment called the hometown heroes. These are the people from Kansas City or Philadelphia. They may or may not watch football during the normal season, but we would see in their location data that they live in one of these two cities. The cities get really, really excited. Sorry, the Colts have not been to a Super Bowl in a while, so I don't know if you remember. Um, but the cities get really excited. Even like the zoos have the animals play with things. The museums have different things up. It's really exciting. And so think about some of the people that might be in those cities. They might not be football fans, sports fans at all, but they might kind of get really excited about today. So if you look at their stats, their data, you might see that they have never watched a football game, maybe ever. They don't buy NFL tickets, but their location data would say they're in Philadelphia or they're in Kansas City. You might see if you had taken a poll that they plan to watch at home or at a Super Bowl party. So think about what you could then start to do. If you were marketing, maybe you would start to market day after deals. Hey, if your team wins, we're going to say all Kansas City locations of this particular restaurant have a deal tomorrow. Or big I keep going back to museums and zoos. Maybe they start to have promotions and, hey, look at this cute thing that the zoo is doing. Again, if you're not a football fan, you might not really appreciate the Chiefs or the Eagles, but you might key into, hey, that's my city. That's really exciting. I want to go see that and be a part of the community, the hometown feel. The next group, I would assume there's going to be some just classic football fans, whether, and realistically, their team's probably out by this point. There's only two teams left. But these people are huge football fans. They've watched their teams all year. They're going to argue about the refs being on one side or the other. They're going to argue that their team really should have had the MVP and they should be in the big game. But they're going to watch the game. They're going to watch it at home. You market to them a little bit differently. So you're going to focus on the football aspect. You're going to focus on the stories of the athletes. You're going to focus on ticket sales and gear versus the hometown heroes. They don't really want tickets. They probably don't want a jersey, but the football fans do. That's what they would respond to. And then finally, I don't know if I can move my, I can. Okay. And then you have the party goers. These are the people that may have just recently found out that it's Super Bowl Sunday. And I put there, can we mute the game between commercials? They're here for the fun. They're here for the socializing. They're going for the party and the wings and the nachos. They don't really want to watch football. So they're the ones that are really there for the commercials, and they're the ones the marketing people love because they really don't want anything to do with the football, the athletes, anything during these commercials. They want to focus on what can I buy? What's kind of fun? Let me get some celebrity influencers up there. Let me get some still deals, things that I can purchase. But I'd actually prefer if it wasn't geared towards anything related to football or Kansas City or Philadelphia. So that's kind of an example. Sorry, I'm trying to move myself so I can see. But that's an example of how we could start to cluster. So based on data, we start to figure out how can we group people together. Now, in marketing, we would do this based off of surveys and focus groups and figuring out, based on more qualitative data, a lot of times who's in my in my marketing campaign, who's going to watch my commercial. But in data science, we do this through clustering. So there we go. We would typically, and as always, we're going to plot this on a 2D chart to start. We're going to add more and more variables in to where our brain can no longer see this nice, neat clustering situation. But say, for example, we start off with number of tickets purchased and amount spent on or minutes watched of football. So over here, we've got the huge football fans. They have watched so much football this year. They've spent a ton of money. They are in it to win it. And then you've got the people over here. They didn't spend any money on tickets this year, but they watched a lot of football at home. Maybe they're more socializers. And then here, maybe you've got the hometown people where maybe they spent a little bit of money on tickets just for fun. They wanted to go to the game, but they didn't actually want to watch football. So in an ideal world, we could split up our data really nice and neat like this. We plotted it, and you can see clearly, oh, there are 3 distinct groups. Clearly, we are going to see 1, 2, 3 clusters. We're going to group these into 3 clusters. And K-means clustering, and I will get to in more detail in a moment. We are trying to make clusters where each of these dots are data points, and each of our clusters are as closely knit as possible. We want our clusters to be really closely grouped, and we want each of our clusters to be as far away from other clusters as possible. So within each of these clusters, the data points are close, and each of our each of our clusters are far away from the other clusters. So we want distinct, we want very clear. In the real world, we're not going to see this kind of data, unfortunately. I wish. We're going to see something like this. And even this is kind of a nice one where we can still kind of see 3 nice little groups. You have one down here, one right there, and one right there. And if you color code it, here you go. Where this one's a little more densely packed, this one's a little bit more spread out. Oops. And you see here in the middle, that's where you've got those data points where you could really have put these people in one cluster or the other. It was really a flip of a coin. But that's where the math comes in. And thankfully, the algorithm is going to do that for you. But it's going to try to figure out mathematically, how do I divide these clusters up so that the clusters are as far away as possible from each other, and the data points are as closely knit within that cluster as possible. So again, the general idea of clustering, we're going to try to find distinct patterns. When I say patterns, segments, clusters, whatever it may be, but we're going to try to find those groupings, and we're trying to find the mathematical distance. I'm not going to go into a ton of details on the mathematical distance, but there are lots of different points you can use: Euclidean distance, Manhattan distance. If you want to dive deep into this, I'm happy to chat, but there's lots of detail you can go in deep on if you want to get really deep on K-means. But the big key point you need to know here: clusters should be far apart from each other, and data points within a cluster should be tightly knit as possible. When we're looking at K-means, though, the big part we need to think about, yes, we want the clusters to fit that mathematical piece. The bigger part is that we want to formulate the problem. We want to really think through that business part. Because as I mentioned at the beginning, our algorithm is going to find patterns even if they're not really very distinguished. So we want to make sure our problem set, what we're trying to do with our data, is as clear as possible. Because even if our clusters aren't the best, most distinguished clusters, if we can do something really interesting with them, that's where the magic happens. So it's okay if our football fans are our hometown heroes, there's a little bit of mix up. There's some people that could be in one cluster or the other. We want to make sure our business case is sound and we know what we're going to do with each of the clusters. And that's where that variable selection can really play a huge part in here. We don't want a lot of irrelevant variables. So think about, what are you trying to do with the business problem? What are you trying to solve? What are you trying to accomplish? And which variables are actually critical to that? And as you do that, I don't think I have this in the slides. It'll be in the Python exercise, though. Your variables need to be scaled in some sort of way. So because we're doing mathematical distance, we don't want variables that are, for example, amount of money spent in US dollars and minutes watched of football. Those are 2 totally different scales. So when we try to do the mathematical distance, you can see where we start to have some problems where we're not putting things on the same axis, and suddenly these clusters are not going to make any sense. So these selected variables, whatever we do select, they need to be focused on the problem and only the problem. We should not be putting variables in just for fun. So K-means clustering. It's the most common one that is used in data science. It is one that I bring up in data science interviews all the time. My go-to question in data science interviews, spoiler alert, if I ever interview you, is how do you choose K? And I'm asking that not because I want people to memorize it, but I want to hear how they think through it, how would they answer it on the spot. Um, but in general, the goal with this, again, and I'm going to repeat this over and over because I don't care if you know the mathematical part of it. I want you to know in business terms, the goal is to find clusters where the objects, the data points, are most similar to each other. So they're closely wound together and the clusters are distinct from each other. And then just a note K. So K is the number of clusters. So K means we could have one cluster, not as useful. That just means every data point is together. We could have 10 clusters, 100, 5, any number that makes sense. That number, though, must make sense with the business problem. So, how the algorithm works is that we are going to partition items into K clusters, so the number of clusters that we have chosen. And then the algorithm assigns each data point into the cluster with the closest center. So, it's going to find the centroid of the cluster, the center point, and it's going to figure out, okay, this is the closest point for you. This is the closest cluster. This data point goes with cluster 1. This one goes with 5. This one goes with 7, whatever it may be. And then once every data point has been assigned a cluster, it's going to then recalculate and say, okay, now where's the center of the cluster? Then it's going to do it again. It's going to continuously do this until it has stopped moving, essentially, and no one else has moved. And a great way to visualize this is here. The link is in the slides. And I'm just going to do this. So if we have data like this, for example, we've got, it's kind of hard to tell. Maybe there's a cluster here and some clusters over there, I guess. What if we tried to have 3 clusters? So I just said add points randomly. It added some points randomly. And it's going to say, okay, I'm going to assign the points. So it's going to make all of these green, all of these blue, all these red. Now it's going to say, okay, but where is the center of the green now? So if I had to guess, it would move a little bit over here. It's going to go based on the distance, and it's going to look at where these points are clustered the most. I hate to use the word clustered because that's where we're going. So it's not going to move too far over here because there's less over here, but it's going to go a little bit over here. You see that? And now once it did, you see some of these points, they're blue, but they should be green now. It's going to reassign. And then it's going to do it again. So it's going to update. So update the center, reassign. Update, reassign. And at some point, okay, it has stopped moving. These are now our clusters. And you see how it's probably not the best clustering because I can physically see this is a really great cluster right here in the middle, but it divided them into 2 different clusters. That's what I meant about it's going to find a pattern. It might not be the best pattern. So let's do again. I'm going to do, let's do, so this is a nice, easy one. So there should be 3 clusters. So the points were added randomly. So let's see how long it takes us to get to where they should be. So 1, 2, 3. Oh, it only took a few times actually. So it moved really, really quickly and it assigned those points now. And then let me do one more time. Let's do these. No. Let's do a pimpled smiley face. So it's a smiley face with pimples on it. And let's do maybe 5 clusters. So 5, 1, 2, 3, 4, 5. Yep. There we go. So you see how it works. It's going to shift slightly until it's set and it doesn't need to move anymore. So some of the strengths of k-means, it's pretty simple to understand and to implement. If I explain it to someone, it depends on the day if I explain it well, but relatively easy to understand, especially if you start with a few data points and start to explain it from there. The more data points you add, it can be more difficult to explain because you start to get into a multi-dimensional space. But with like a two-dimensional space, you could very easily explain, like that football example, the number of tickets and the number of minutes watched of football. Time efficiency, it is very quick normally. Computationally, it doesn't take a lot of computational time to run the algorithm at all. It's not too bad. Weaknesses, categorical variables can be kind of rough. So if you have a categorical variable and say it's a binary, so zeros or ones, think about what that would do to your data points when it's getting the mean of some of these and it's finding the center. That would be kind of rough because you're plotting, and if it's just a 0 or 1, it's there or it's not. That's not so great. So it works best with numeric values. You still can use categorical values, but do make sure that your data is scaled and try to limit your categorical variables if you can. It just works a lot better. And it is very sensitive to outliers. So again, that's why you scale your data. Don't leave in lots of different widely varying scales. Scale your data. I personally like to do a 0 to 1 scale if I can, if it makes sense. But it depends on your data and how you want to interpret it. But 0 to 1 just makes it nice and easy, so everything's on a nice uniform scale. And then the fun part, choosing the number of clusters K. That's where I mentioned this is my go-to interview question, because some people go about it the mathematical way, which should be part of your decision making. And that's where you minimize the space within a cluster. So, like I said, the data point should be tightly knit. You are, in a mathematical term, you are minimizing the space within a cluster, minimizing. And then you want your clusters to be distinct, so you're maximizing space between them. But you also have to remember the business case. If you find out that the mathematical best number of clusters is 117, but you're going to use these clusters for marketing treatments. If you go to your marketing team and say, I have got 117 different segments of customers, I need you to come up with 117 different treatments, they are going to laugh you out of the building. So try to limit your K if it makes sense. So an example of mine, I have done this quite a few times, and I always come up with the K is always like 19 or 27 or something ridiculous. I always scale it back to what's the what's the K I can get away with that makes sense with what the business case is. And that changes a lot depending on what I'm working on. I'll show you a few examples here at the end. You have to balance out the mathematical with the business case. If you're going to go the mathematical route and you forget the business case, it's not worth it. If you only focus on the business case and you throw out the mathematical piece, though, remember this algorithm will give you an answer. It might not be a good answer, though. So you still need to remember the mathematical piece. And the other way I do like people to answer this is the elbow method. So this is where you look at the sum of squared distances and your K in the elbow method. So you're looking at your elbow, you want that point. So here the best point would be about a 5 or 6. So you want to minimize the sum of square distances, go for the lowest K you can get away with while minimizing square distances. Because the more K, the higher K, the more clusters you have, that's going to be better. If everyone could be their own market segment, that would be the ideal case. If I was a business and I could market to every single person individually, I would get the best sales ever. That's not realistic, though. So we want to balance out the sum of square distances, the distances within the cluster, distances between the clusters. What can I get away with and solve the business case while looking out for the mathematical piece? And then you start to get into actually interpreting your clusters. So you've created your clusters, you figured out K, you figured out what you're going to do, you knew what variables you were going to put in, And that's where you come up with what treatment are you going to do? How are you going to interpret these clusters? And that's how I started at the beginning when I talked about the hometown heroes and the football fans. That's where you actually kind of have some fun with it. So you get down to, okay, cluster one. What attributes are going on with cluster one? What variables are they over indexing on? So, what variables kind of stand out with cluster one? What makes it different from cluster two or cluster five or any of the other clusters? Name it something interesting. That's kind of the fun part of clustering. And then start to understand, how does that relate back to the business problem? And then again, the validity of clustering. If it does not match the business case, it is not valid. You have to be able to bring it back to the business case. What are you trying to do with these clusters? And I'm actually going to skip ahead of the business case, yes, because I think this is going to make more sense. So an example from my work, I worked at Sprint for a short bit before they merged with T-Mobile. And the slides I prepared here were for an interview for a job I ended up not taking. I didn't like the company. So you'll notice some pieces are oddly vague, but it was for Sprint. I figured it's okay to tell you now that they're not in business. But in general, what I wanted to do, if you are at a telecom company, you want to reduce churn. So anyone with a phone, at some point you thought about leaving. If your cell service is bad, just anything goes wrong, you immediately say, I'm going to start shopping around. So our starting hypothesis, my boss had this fantastic idea, and he was thinking, if customers move, they have a higher churn rate than those who do not. But there's no moving form, there's no thing you put in to change your address. And oftentimes when people do change their address, it's months later. So anyway, that was the starting hypothesis. It went way off the rails after that. But I started from that point. Okay, I want to reduce customer churn. So I want to figure out who churns. And I want to know based on how they move about the country, how they use their phone. And I also want to focus in on what attributes that I know about how they use their plan, how long they've been with Sprint, what kind of phone they have, all that kind of stuff. So can we prevent customer churn by understanding customer movements between cell towers? So available data, we knew their phone type, their plan type, company tenure, how long they'd been with Sprint, call and text usage, so how many calls and texts they make, and also how long they stay on the phone, dropped calls, roaming charges, data, number of towers they use. So if they're pinging off of a lot of towers, where those towers are, usage per tower, all of that really interesting stuff. And I started to dive in. And as I started going, I was finding some interesting things. And I found pretty quickly that I really needed to take a two-step approach. So this first approach has nothing to do with K-means. It's just to set up the first part. So I'm going to go through it really quickly. And the second part is K-means. So the first part is I figured out that there are distinct travel patterns. I called them network footprints, and it's how people traveled throughout the US. Now, this is pre-COVID, but essentially I figured out through looking at a lot of research on US travel studies and then customer tower maps, I figured out that people basically were in 5 different categories. You were, just some details if you want to look at it later, but you could either be a resident, that's 20% of all subscribers. That's my old house in Kansas City. But you did not move away from your house. So you probably worked from home, you were retired, you lived here, worked there, you just did not move very much. You were a high churn risk if you were in this group. The next one was commuters. So you probably lived in one suburb. You lived in the suburb and you worked in the city, or vice versa. You did move a little bit, you traveled a little bit, but not as much as other groups. 5 to 15 miles. That's about your monthly radius from your center point. And you typically they didn't leave as much as others. Weekenders, they were the ones that had a slightly wider radius. So we're slowly going more and more. They are hitting more cell towers. So they're hitting a wider radius. Vacationers, so they're going more and more about the country. These are the people that are hitting about half the country in a given month. Low churn risk. These people do not typically churn. And even lower is the travelers. These are the people that are hitting about half the country and also like north, south, east, and Midwest. So they are going a lot of distance. They're traveling quite a bit. Their center point is so far away from some of these other points that they're hitting. They had some of the lowest churn risk. We had a lot of ideas about why this might happen outside the point. So we segmented customers just solely based on how far do you travel. So you could do this in Excel. This was figuring out your towers and how far do you travel from them. This next part was the k-means though. So we took the residents, ran them through k-means, and then we figured out what clusters existed. So we did this because we knew, okay, if 40% of all customers are commuters, I know there are patterns within that. I know there's something going on. And thankfully, there were a lot of interesting things here. So we figured out that k equals 5 was the optimal. Look how smart I sounded back then. We found that k equals 5 was the best number of clusters that fit our business case. 5 was a very reasonable number of clusters, and it also happened to fit the number of network footprints. That was just a coincidence. So we ended up with 25 different marketing segments, but we only had a few that we actually needed to find a treatment for. All of the clusters were the same for each group, interestingly enough. And I'll show you. So we had new iPhone users. So when we clustered their data, again, we had phone, we had usage, we had what type of plan, how many people are on your plan. So some of them were iPhone. They were new to Sprint. They had the brand new iPhone. And you notice that almost all of them had really low churn risk. Mid-range Android users. So they had not the newest Android, but they had a decent Android phone. That was what they over-indexed on. So that was the data point within that cluster that stood out to me. You notice all of these, not a lot of churn risk. Sorry, I have to keep moving myself. I can't find a good spot for me. What we found, the people that were at highest risk, so we knew residents were at higher risk, but the ones that were at the highest risk of all of those were heavy data users, young lessees, so people that were leasing their phones, and then tenured families that had been around Sprint for a long time, and they were residents, and then tenured families that were weekenders. So we really only had 4 groups that we had to focus on. If we had only focused on this part, we would have missed out on that information. If we only focused on k-means, we would have missed out. So we did that in 2 steps just to figure out exactly which piece. But because we were able to take all those data points, I'm going to take credit for it. I did all of it. I found the data points that stuck out, and then I just named these so that the business users I was talking to would understand that I meant heavy data users. They're using their phone a lot. That means they're probably using a lot of towers. And if the towers go down, there's not a good data connection. They're going to get roaming charges, or they're not going to have a good connection. Young lessees, they probably have bad credit, no credit. They're building credit. They don't have a lot of cash for new phones. Tenured families, they've been around a lot. They know other plans have better deals. And if they're weekenders, yeah, they're traveling a bit more. They probably go to other locations and see, hey, Sprint's actually really good at home, but it's horrible at the lake, or vice versa. So we are able to find just 4 small groups of customers, and we're able to find a marketing treatment, all based on clustering. So it was a really neat activity, I hate to call it activity, research experiment, and they were able to put this into their database so that if a tenured family in the resident category called, we were able to then say, yes, put them to the top of the queue, give them something to keep them there because they had the highest churn risk of everybody. And that's just what happened after. The other piece is not k-means, but it's another example of a type of clustering. So I work with text a lot. And if you take my text mining class later, you'll hear me talk about this. But I took nonprofit job posting data. So job postings, we got it from a company called Idealist, but think like LinkedIn job postings. It was 12,000 of them. I ended up with like 25,000 by the end of the project. But I essentially said, how can I group these job postings and figure out what kind of patterns exist? So we did that. I did that. And it's called non-negative matrix factorization. So again, not k-means, but a very similar type of clustering. This one's specific for topic or for text mining, but it picks up on specific words that are used. So instead of data points, it's data points based on text. And it's going to say, ooh, this is based on leadership, this deals with communication, and this deals with technology. And then I was able to find different topics, different clusters that popped up. So I was able to take all of the 12,000 job postings and then figure out these are the topics, these are the clusters. And then from there, we then were able to attack the research problem more efficiently. So what can we learn from each topic? How do you compare different topics to each other? So again, k-means is not the end of the research. It's not the end of the problem. It's really the first step. And then from there, you can start. Are you going to market to them differently? Are you going to treat them differently if they call into your business? If you're trying to reach a certain segment of the market, maybe you can start to understand, ooh, these customers are like others. In cybersecurity, you can cluster access and start to see, ooh, these are nurses gathering things. These are people on the back end working. But these data points do not belong to a cluster because these are potential fraud. So clustering is a really interesting way to start to group data points together. I keep saying people, but these data points can be anything. It can be purchases, it can be people, it can be whatever it may be. But you are grouping data together so that you can then understand what patterns are in the underlying data. It is unsupervised because we do not know the patterns. You are still involved, you're still trying to figure out what variable should I use, what's the business problem, how do I understand what to do next. But from there, you really get a lot of creativity. This is one of my favorite methods because it's really the best example of the mix of art and science available in data analytics. You get to take data, run it through an algorithm, and then figure out what comes next. With that, have a fantastic week. Hopefully, this doesn't jinx me, but go Chiefs. Hope you all have a great Super Bowl Sunday, and I will see you next time. Bye.